Hi, my name is Tim Cruse. I'm a Principal IoT Specialist Solutions Architect at Amazon Web Services. Welcome to the AWS Online Summit. In this session, I will walk you through how we are using AWS's IoT Data Analytics services to help our industrial customers gain access to their locked industrial data, bring their data easily to the AWS cloud, visualize their data, and then eventually unleash our powerful analytics and ML engines on their data to generate meaningful and digitally transformative insights for their enterprise. I will spend the first 15 to 20 minutes providing you with a grounding in the problem of locked industrial data, followed by a review of a high-level architecture and a more detailed architecture that we have used with industrial customers to help them extract their data and build industrial IoT solutions to solve business problems. And finally, I will demonstrate an actual solution that we have built for customers. With that, let me discuss the fundamental challenge of liberating locked industrial data. Customers tell us that they have been collecting data in the field for a long time, often 10 to 15 years. Their field, SCADA and historian operators have seen the data locally, but beyond that, at an enterprise level, they have rarely seen their data in a centralized manner, across assets or geographies, or integrated with other kinds of data. In this data-driven world, they are recognizing that this is a major waste of a critical asset. They are itching to use AI and ML to capture those exciting insights everybody talks about, but they have to do the basics first. Our approach is simple. First, we recommend you get your data up to the cloud so you can visualize it in real time or historical or both. Get a good feel for your data. Then identify specific business problems you want to solve and collect as much data as you can to address those problems. Only then should you start to apply AI and ML techniques to begin the journey from descriptive to preventive to predictive analytics. We tackle solution building in this area with a simple and intuitive high-level architecture. At the core is an AWS Data Lake, a unique structure that allows customers to aggregate data across myriad data sources with disparate formats and schemas. For example, from on-premises data repositories like historians, ERP, and MES systems, or directly from field assets like Allen Bradley or Siemens PLCs, and to index all of that data for analysis. The data becomes ready for business problem solving with the use of simple ad hoc query tools or more complex machine learning services. Now, let me drill down another level. Here are your field assets, PLCs, SCADA, or historians. We then layer in industrial gateways from our hardware partners to assess your data. These are running key AWS IoT Edge services like IoT Greengrass and IoT Sitewise Collector. They may also be running protocol converters from an AWS partner like Kepware to convert your industrial protocols to MQTT or OPC UA, which can then be consumed by IoT Greengrass and IoT Sitewise Collector to push up to the AWS cloud. This data is ingested into our cloud via IoT Core or directly into IoT Sitewise for viewing in our Sitewise Monitor operational dashboard, giving you an initial look at your near real-time data. You can also do basic or complex condition monitoring of the data streams with IoT events. If you like what you see, you start collecting that data and maybe mixing in other data in an AWS Data Lake, and then start visualizing your data with our BI tool, AWS QuickSights. So far, you have just done data monitoring and visualization. You may now be ready for heavier analytics using Amazon Athena for ad hoc querying and Amazon SageMaker for building machine learning models. This is where the real business problem solving starts. Machine learning models can be built for a wide range of classic or custom use cases such as product quality improvement on one end, to predictive maintenance and process optimization, to scrap and theft prevention at the other end. As I just discussed, data in on-premises data stores is not discoverable centrally and that makes it difficult to analyze it without going through a complicated extract and copy process using proprietary tools. Pretty much every customer we work with wants to use AI/ML for operational efficiency, but they are very early in their journey. To address these pain points, we recommend that customers start with a secure industrial data lake, which has the ability to collect and store any data at any scale and at low cost. This not only includes your streaming and historical data from your on-premises PLCs, historians, and SCADA systems, but also includes your operational enterprise data from ERP systems, third-party data like weather data, etc. Basically, you want to bring all of your relevant data to solve a specific business problem to one secure home and hence avoid data silos. Once all your data is in one home, you can now democratize access to that data to your industrial analyst based on their entitlements to explore and find insights which were either never seen before or were extremely difficult to get to. More importantly, you now have a choice of tools to do this job. You also likely have multiple internal and external applications, most of which are on-premises. Hence, you want to build and expose RESTful APIs in the matter of minutes to access your data from anywhere securely. And to that, we apply a few key principles to build a production-grade industrial solution. The solution should be scalable and cost-effective by using fully managed, auto-scalable, serverless, transient, and pay-per-use AWS services wherever possible. The solution must have security as priority 0. You want to enforce encryption at rest and in transit for all of your data from field to cloud using either AWS managed or your own encryption keys. The solution should enable developer and data scientists to easily explore the data with machine learning and other analytical tools, while leaving the undifferentiated heavy lifting of model building, etc. to AWS. With streaming data, the solution should allow for near real-time operational dashboarding to visualize key measurements and metrics and send notification and alerts for actions to your operations team. And the solution should enable your legacy internal and external apps to access the data and insights via APIs for flexible access. And last but not least, the solution should enable you to build reports and present analysis without having to use a client-server model, but instead access this via BI tool with per-session pricing. So here is how we do it in practice. We start from your PLCs, which are collecting real-time data. This data is converted at the field level into an OPC UA stream using services like KEP-Server-EX. Then the data goes to a customer business data center with firewall protection, where we have an industrial edge gateway running AWS's IoT Edge Compute Service, IoT Greengrass, which in turn is running our OPC UA data collector, IoT Sitewise data collector. These industrial edge gateways, which are compatible with Greengrass and Sitewise collector, are built by many OEMs. From the business data center, the data goes through further customer OT-IT separation firewalls to get to the AWS cloud, to our cloud-based IoT Sitewise time series data store. This data store is accessed by an operational dashboard called Sitewise Monitor, where customers can see their data, look at trend lines, and perform analytics. We then use IoT Analytics and IoT Events to monitor the incoming real-time data and generate alerts via Amazon Simple Messaging Service. This alerting will be built into the IoT Sitewise Monitor when we go GA shortly. IoT Analytics also performs ETL cleanup on the raw IoT data that came into the Sitewise data store and gets it ready for machine learning model building with Amazon SageMaker, which can be used by your data scientists when they are ready to start exploring machine learning models. The ETL cleaned up IoT data is then stored in the data lake, where it is indexed using AWS Glue, which enables simple SQL querying using Amazon Athena and visualization of that output via Amazon QuickSight by your managers and data analysts. The entire solution is secured and monitored with enterprise-grade AWS security. You can also bring in your historical data directly into the data lake using our physical transfer services such as AWS Snowball or our migration services such as AWS Data Migration Service. Finally, You can extract the data from the new data lake via our API gateway so that it can be fed into your legacy applications. When we put it all together, this end-to-end field-to-cloud architecture allows you to liberate your locked industrial data, bring it up to the AWS cloud, store it very inexpensively and securely, clean it, and append it to be able to generate insights using our analytics and machine learning engines, and still continue to access it for use with your legacy applications. For this demo, I've asked my colleague Rahul to help out. Rahul, over to you.
Thanks, Tim. Hey everyone, I'm Rahul Sareen from AWS Professional Services. I lead emerging services for IoT, Sumerian, blockchain, and Alexa in Asia Pacific region. In the following demo, I will show you a step-by-step walkthrough of an end-to-end solution for a wind farm use case using AWS IoT Sitewise. Let's get started. Running CapServer EX, a trial version, and I have a bunch of data being simulated using their simulation driver. You don't need any license for the simulation driver. You can run this as long as you want, just so that you know it never expires that way. So that's kind of good. In this case, I have a wind farm use case where in the energy sector, right? So I have 3 wind turbines, 1, 2, and 3, and each one has 2 PLC units. One of them I'm calling it unit 1, the other one is unit 2. For the first one, I have 3 tags. Remember I mentioned about tags, so it's basically one of them is generated power, rotor speed, and wind speed. And then the unit 2, if you go, it's like equipment temperature and outside temperature. That's all it's tracking. If you want to see how the values are being generated or simulated, there is this thing called Quick Client. They provide it out of the box, so you could just go there and choose, one of the wind turbine PLC. You will see how the values are changing, which means it's simulating data. So I am capturing data from CapServer, and then the data is coming and landing in AWS IoT Sitewise. And then, like I said, I have my Greengrass and Sitewise connector running on an EC2. In Sitewise, I have something called a gateway. This is like think of this like a logical gateway, not a physical gateway, but this is where you basically say where to pull the data from. And as you can see that I have a source, and for my source, I have something called an OPC UA endpoint. And this IP address is the IP address of the CapServer machine. And this is the port in which it's listening. It's basically getting the data from CapServer through Sitewise connector and Greengrass, and it's bringing every tag data for these 3 different nodes. And then it's also doing a handshake with a security policy named as basic 128 RSA 15. So there is a certificate you have to trust before the data is sent to the cloud. So there's obviously security in place. Once your data comes to Sitewise, remember I mentioned you need to model it. So for my wind farm, I'm going to show you the asset tree first. That way you will know, like why the models are done that way. So I have a wind farm, I have 3 wind turbines. And then if you go to each wind turbine, that has 2 PLC units, just like what you saw in my CapServer. So that's how I modeled it. If you go to wind turbine 1 PLC units, you will see on the right side that you can define attributes. You can define, what's the name of that, what's the model number, and things like that. And then these are the measurements coming from the wind turbine PLC unit 1. And I have three tags, because in CapServer I showed you 3 tags: generated power, wind speed, rotor speed, right? Then in the transform, I'm trying to do something. This doesn't really make a lot of sense for you, I think, but I'm trying to test out something. So I'm trying to create a transform, and then I'm trying to do, is it less than or equal to, the rotor speed with the low limit, or did it cross the threshold, and things like that. Then coming to metrics, this is where I mentioned that you are doing some average calculations. Like think of this like a moving average, average, max, and state time. State time is something like, how many times that condition was met within the last, whatever the frequency you have defined for this metrics. And then on the right side, you see these latest values. It's just saying that my data is flowing and I'm getting data from the source. But this is really the asset you create. But before you create asset, obviously you have to create a model first. And that's where I have 4 models, one for PLC unit 1, one for 2, and then one for wind turbine itself, one for the wind farm. Model is, think of this like a template. So think of this like you have 10,000 sensors on the field, but all of the sensors are from, let's say, 10 different manufacturers. So you need one model per manufacturer, and then all you do is you instantiate that model to number of assets. So it's similarly like, you know, creating a class and then instantiating the class, right, in a programming language. So think of that way. So you create 4 models and then you instantiate them as assets, right? So like for unit 1 PLC, you will see that I have 3 assets, literally just that. Once you created the models, that's the first thing you do. Then you create assets. Remember I said that you need to turn on something to say, make this data also available in IoT Core rules engine as a topic, right? As a message broker pub sub, and this is that status. So by default it is set to disable, and I have enabled them because I need all this data to go to my data lake, which is why I've done that. So you can enable them for all attributes, all measurements, all metrics, again depending on, you know, what you want to take it to the data lake. So far I want the measurements and I also want my metrics, which is why I have enabled this too. I haven't done this one yet because I don't think I need it yet. But bottom line is, you know, those are all things you set it up in the asset model. Once your data, you know, once you've defined the model and the assets and you have mapped your tags to the asset properties, you then go to this portal thing. If you remember, I mentioned about an operational dashboard out of the box. It's a web application, just like how you go to QuickSight. So this is where I am. You don't need to be in AWS console to be on this website. All the users will have on the floor is this URL to go to with a credential. So I went there, and one thing to keep in mind is this website works with an authentication of AWS SSD. And then I have a project within the website. I have a project within a project. I have dashboards, and then you can create dashboards. You can share dashboards, you know, with users. And this is basically the dashboard, a quick version of how it looks. You will see the values are changing. You can change it to, you know, the last hour or last day, things like that. You can pull, you know, multiple metrics under one particular chart. You can edit it. You can go and switch between the charts. So right now there is a line chart, bar chart, and then there is a KPI as well. So that's the site-wise monitor piece of it. Going back to site-wise again, if you remember that I'm sending my data to IoT Core rules engine. So if I go back to IoT Core, you will see that I have some rules defined there, which says that grab my data. I believe this is the one. No, that's the Firehose. This is the one for IoT Analytics. So I'm saying that capture the data for these topics, and these are the topics which is where Sitewise is publishing the data, and then I'm saying send it to IoT Analytics. So if I go to IoT Analytics, IoT Analytics has a channel, pipeline, data store, data set. You know, again, if you're not familiar with the service, think of this more like an ETL service for streaming data. So channel is where your data lands, and this is where the data is landing, and you will see that it's flowing. It's flowing for last probably 2 days because the demo was set up a couple of days ahead only. But bottom line is your data is flowing through the channel. I have a pipeline, which is where I have a Lambda. And if you want to see, you know, how your messages look coming out of Sitewise, they look like this. And there is an array. And because there is an array, it's not easy to read it in a SQL, like Athena SQL or, you know, IoT Analytics SQL. So if you then go to next, this is where your data came in. And then if I show you, you know, what the Lambda does, you will see that all it does is it just flattens it, more like a rows and columns. That way you can query this data. So that's all this pipeline does. And then from pipeline, you land the data to a data store. So think of this like a source and target, right? So that data store is living on S3. But again, like I mentioned, I have IoT events doing the alarm side of it or alert side of it. And from IoT Analytics, I have a data set named IoT equip temperature data set. So I have a temperature monitoring, which is looking at the data for last, it's running every 5 minutes. It's looking at the data from last 5 minutes and for certain number of assets. And then it's saying that what is the average equipment temperature? So they're all in 86. And then it's feeding that to an IoT events, which is what is monitoring those 3 units, right? So if you go to IoT events, you will see that there is a good and critical state, and then this is where the data is coming, and then it's being monitored, and you can define all your rules here saying when to alert and when not to alert. So it says, if the critical counter, if your temperature crosses certain threshold, which is an increment counter, if the temperature crosses 70, then increment the counter. So since my temperature is 86, it's going to increment it. And then as soon as it's more than 2 times, it's going to send it to critical state. And it is in critical state, which is why you basically saw that, and when it's in critical state, I have an SNS message coming to me, right? Just typical alert stuff, right? You see all these 3 units are in critical state right now, but they will go back to green if the temperature falls below 86, which probably won't happen because my data simulation is producing somewhere around that 80 range, okay? But you get the idea. So once your data is in IoT Analytics, like I said, your data is already in S3. From here, I have a glue crawler which is running, and I'm not going to go there because that's going to take time, but I have a glue crawler which is running every 5 minutes. It's capturing all your latest data. And then this is the Data Lake Athena Glue Catalog database. This is where all your data landing from IoT Analytics data store. And then obviously as simple as, you can preview your data from here. It's as simple as you go to QuickSight, and then, I have a data manage data. If you go to there, you'll see that, I have a data set created for that same data set, but I'm pulling only about 6 hours worth of data. That's about a little over 500,000 rows, right? And then I have an analysis built up, but just to showcase that you can then go here, play with the data, drill down, however you want to do it. And this is exactly, one of the common use cases for a lot of industrial customers, because the data has been locked in many sites in their proprietary thing called historians, and then bringing all that data under one storage, and then also enabling BI reporting as well as operational metrics dashboard and bunch of these other capabilities. That's really our distinctive advantage with the service. They ask for, what happens to my historical data sitting in historians in the on-prem? What do I do with them? How do I bring it to cloud? So basically usual path, Snowball and DMS, depending on if it's a database and if the historian continues to exist in a hybrid mode where you want to continue to bring the data to cloud for all your analytics happen in one place. That's that. And then obviously if you have a lot of legacy applications, a lot of industrial customers, you will find a lot of .NET applications, Java applications, stuff like that running on-prem. You cannot flip the switch overnight, but they need to continue to get the data, which is hosted in AWS now. So an usual path is you build basically an RESTful API path for it.
Thanks, Rahul. So thank you again for attending this session. Learn about IoT with AWS training and certification. Grow your skills with us with expert content. Thank you, and we really appreciate your feedback so that we can better understand the topics and services you would like to know more about. So please do take the time to fill out our survey and let us know what you think.